The last topic in our lessons with dealing with mainly with operations with radicals deals with dividing radical expressions. Now, it's a little bit of a misnomer to say that we're going to divide because what you're going to see is most of the times we're not going to be actually dividing, but we're going to be doing what's called rationalizing the denominator. And I'll explain what that term means in a moment. Now, a radical expression is in simplest form when, number one, we've simplified all of the radicals, meaning there's no radicands that have a perfect square that can be divided into them. That's what we did in that first lesson, so that's what we're talking about in that statement. Number two, no radicands contain fractions, and no radicals appear in the denominator of a fraction. Okay? And that last one is what we're talking about today. So the steps: determine if the fraction contains perfect square radicals that can be simplified. If not, multiply the numerator and denominator by the denominator or conjugate. You may be able to simplify first and make sure the final answer is in simplest form. Okay? A lot of statements, but when we go through some things here, hopefully it'll be a lot clearer to you. Now, similar to what we did with multiplication, our division rule tells us that we can divide the coefficient parts, that's what A and B are, and then we can divide the radical parts. Okay? We can't mix up radicals and non-radicals. So let's talk about a couple of examples first. What we always want to do is see if we can somehow either have or obtain perfect squares. So if you look at the very first one, we have the square root of 4 divided by the square root of 9. And we don't have to write it, but we can visualize it like this, which means it's just simply 2/3. Okay? Now, in the second example, neither 75 nor 3 are perfect squares, but if we do the division first, we get the square root of 25, which gives us 5. So those are the types of things that we want to look for right away. Right? Now, if we look at the next one, 1 over radical 2, neither of the numbers are perfect squares, or nothing that's in the radical 2 is a perfect square. And when we say we want to rationalize the denominator, what that means is we don't want a radical left in our denominator that has is a final answer that is not a perfect square. So what we do is we multiply the numerator and denominator by the denominator. Okay? Multiplying by radical 2 over radical 2 is just multiplying by 1, which means we don't change the value, we just change what it looks like. And we get radical 2 over 2. We've just rationalized the denominator because what that means is the final answer has a rational number in the denominator. Okay? Now, D, we can do one of two things here. We can simplify these first, or we could just multiply by the denominator. The numbers aren't that large, so multiplying by the denominator right away is not too big of a deal. We get radical 96 over 12. Radical 96 is 16 times 6 over 12, which is 4 radical 6 over 12, which is radical 6 over 3. Okay. Continuing on, we're going to multiply by radical 6 over radical 6. 3 radical 48 over 6. 3 radical 16 times 3 over 6. Just move this so I have a little bit more room, which is 12 radical 3 over 6, which is 2 radical 3. Okay? Next one. Now, what's simpler is to just multiply by the radical 2. You can multiply by 3 radical 2. Okay? But it's easier to do this. So what does this give me? 2 radical 24 over 6. Okay? Radical 2 times radical 2 is 2. 2 times the 3 is 6. 4 times 6 over 6. 4 radical 6 over 6, which is 2 radical 6 over 3. Okay? Now, The ones that are a little bit trickier are those that have two terms in the denominator, okay? And if you were to just multiply by the radical, hopefully you would see that it doesn't get rid of the radical, okay? So what we want to do is multiply by the radical and the term with it. But if you think back to your perfect square binomials, what we want to do is have the opposite sign, because then when we do the multiplication, what's going to happen is my middle term is going to disappear. So 4 radical 6 plus 4. And now when you FOIL this, you're going to end up with 6 minus 1, because the two middle terms are going to disappear. In other words, if I do radical 6 minus 1 times radical 6 plus 1, okay, that's 6. That's a positive radical 6. That's here. That's a minus radical 6, and then a minus 1. Well, these two middle terms disappear. And so what you're really just left with is the radical 6 times radical 6 and the 1 times negative 1 times 1. So I get 4 radical 6 plus 4 over 5. Okay. In the next one, I'm going to multiply by radical 5 minus 3. Remember, I have to distribute. I get 5 minus 9. So I get 3 radical 5 minus 9 over negative 4. Okay. Multiplying by radical 2 minus radical 3. Okay, I get 2 minus radical 6 over 2 minus 3, or a negative 2 minus radical 6, or actually, to make it even, 2 minus radical 6 over negative 1, and then I can change that to negative 2 plus radical 6 if you want. It's up to you. Okay. And then finally, I'm going to multiply by radical 5 plus radical 3. I get radical 15 minus plus 3 over 5 minus 3, radical 15 plus 3 over 2. So the point of today's lesson is we want to see if we have perfect squares that we can work with in this. And if we don't have perfect squares, then we have to make sure that our final answer has a rational number in the denominator. That's why it's called rationalizing the denominator.